And this is what we got to almost in last class when we did that solar panel one that we had 70 centimeters on one side and 208 on the other. I think those were the numbers. Here's yesterday's. Whoa. That support cable. This one right here. Here we go. This solar panel one where we had 70 on one side, 208, and we were able to use tangent to figure out that this angle theta was 71.4. And then I proposed that we could try to find out exactly what that length should be so that it was perfectly 70. And I left that for you, and everybody went home and took the time to try that, right, instead of studying for today's quiz. Everybody did this question instead. I'm sure that's what happened. So anyways, what we're going to get to today is for you to check if you did the right idea last night when you were practicing this question. So here's what we can do. Our tangent knows every single tangent ratio. Our calculator has every single tangent ratio stored in it, so then we can now use it to figure out lengths. Here's the first example. We want to determine the length of xy. What letter would I use for xy if I was labeling this properly? Should I put an x here? And why would I use a z? Because it's opposite that capital Z as a vertex. Excellent. So I want to find z, and I know about tangents. I know that tan of an angle, and since I know this angle is 70, is equal to the opposite side over the adjacent side. Now, opposite of z will be z. That's the opposite side. Over the adjacent side to z would be, now is this 5 or is this the hypotenuse? Where's the hypotenuse here? Hypotenuse is down here, right? So yes, the adjacent side is going to be the 5. So I would put the 5 under here, and that is our adjacent side. Now, since your calculator has it stored inside all the tan ratios, if I go to my calculator, I can say tan of 70 is 2.7474774419. Am I going to remember that? No. But I know that this is 2.74 ... equals z over 5. So how would I find z exactly? Multiply both sides by 5. So again, go to my answer. All I need to do is multiply it by 5 and push enter, and I have 13.7. Nearest tenth is what they're looking for. (13.7 centimeters). Now what we're going to want to do in a question like this is I typed in tan of 70 to find 2.74. I had to write the ... to make sure I didn't round to the end. But what we're going to start doing in all of our math questions is we're going to try and rearrange the question first and then do all of our calculator stuff at the end so that you don't have decimals in between in the middle of your question, so you don't get tempted to round early and maybe make a mistake. So this exact same question done again, starting off with tan of 70 equals z over 5. If I wanted to get z by itself, instead of actually figuring out what tan 70 is, I'll just start by multiplying both sides by 5. And then you'll see that you would get z by itself, and on this side you'd have 5 times tan of 70. And when we write 5 times tan of 70, you can put a little x there for times, you can put a dot there for times, or when two things are just touching and no symbol is there in between, that does mean times. And then when I go to my calculator, I type this in all at once, 5 tan 70, and I get the same answer, 13.7. But it means that I don't have to know about the decimal places in between. I know that my calculator knows what the ratio should be, and then we just use our algebra to solve it.